Welcome to Chapter 7, Memory. What could come more naturally after learning than memory? After learning something, you should assess what you've learned and show it by bringing it up from memory. Slide 2. Let's begin with a demonstration. I'm going to read a list of words one at a time, and I want you to listen and memorize the words I'm saying without writing anything down. When I'm done saying the list of words, I'd like you to write down as many of them as you can remember in order. Here we go. Jazz, horn, concert, orchestra, rhythm, sing, piano, band, note, instrument, art, sound, symphony, radio, melody. Now write down as many words as you can remember in order. Slide 3. Let's try another. Again, wait until I'm done saying the list of words, then write down as many words as you can remember in order. Here we go. Rest, bed, nap, peace, drowsy, blanket, doze, tired, awake, snooze, yawn, slumber, snore, wake, dream. Now write down as many words as you can remember in order. Slide 4. One more time. Again, wait until I'm done saying the list of words, then write down as many as you can remember in order. Here we go. Hand, smell, toe, walk, kick, ankle, inch, mouth, sandals, arm, yard, sock, boot, soccer, shoe. Now write down as many words as you can remember in order and set it aside. Slide 5. So this is Chapter 7, the chapter on memory. It's going to be broken down into 3 huge chunks. The first chunk is going to be an introduction to memory, followed by the process of memory, and then we will finish up with memory disorders. Slide 6. Anyone remembers some information and forgets the rest. Memory is the retention of information. It includes skills such as riding a bicycle or tying your shoelaces. It also includes facts that never change, like your birthday. Facts that seldom change, like your mailing address. And facts that frequently change, like where you left your keys. You remember your most important experiences and some of your unimportant ones, many useful facts, and much trivia that you can't imagine ever using. But how does memory work? Is it like a tape recorder that we can rewind? Or like a hard drive we can access? Or like a part of something beyond our material brain? Let's go over a brief history of theories about memory to bring us to a modern model of memory that we will then use for the rest of the lecture to unpack more concepts about memory. Slide 7. At least in written history, Aristotle was the first to propose the idea that complex forms of thinking, like memory, can be wholly or mainly explained by the associative links formed between ideas according to specific laws. This is known as associationism. For example, when you hear a story or a joke that reminds you of another story or joke, it may be because they're associated due to how similar they are. When you eat an apple, you perceive its fragrance, its taste, its flavor, and its texture, as well as the circumstances in which you're eating the apple together in sequence, or contiguously, and therefore associate them together in memory. That is, once you've experienced the joy that is eating an apple, sometimes just the smell of one will trigger the memory of its taste, flavor, and texture, or where you were and what was going on during a particularly momentous apple-eating experience. Associationism was picked up by Enlightenment thinkers like David Hume and others who proposed specific laws of associationism that seem consistent with the ones proposed by Aristotle. In addition to similarity and contiguity, events can be associated if they appear together in sequence in time and look like a cause-effect relationship. Like if you were to get sick immediately after eating that apple, you'd unfortunately associate apples with sickness. Slide 8. Jumping forward a few hundred years, we see Hermann Ebbinghaus, and he's pioneering the experimental study of memory by testing his own ability to memorize and retain lists of nonsense syllables. Ebbinghaus wrote out 2,300 syllables, assembled them randomly into lists, and then set out to study memory. He ran all the tests on himself, and for 6 years, he memorized thousands of lists of nonsense syllables. Many of his findings were hardly surprising. For example, he took longer to memorize longer lists than shorter lists. But Ebbinghaus was not just demonstrating the obvious. He measured how much longer it took to memorize a longer list. Measuring how long it takes to learn a list enables psychologists to compare conditions. Do adults learn faster than children? Do we learn some kinds of lists faster than other lists? Slide 9. The behaviorists were covered as a dominant force in simple learning, and learning implies memory. So guess which form of memory was picked up by the behaviorists? I know. Pick me. Associationism. Yes, indeedy, the form of simple learning that the behaviorists were researching is considered associative learning, and it relies on associative memories being built between stimuli and responses. But we've already addressed the fact that associative learning only helps explain simple behavior, and it's quite limited when explaining more complex learning. Slide 10. This is when the cognitivists step in and say, hey, hold my beer. This new computer thingy seems to provide a model of the human mind that can be used for testing. Roughly, cognitivists laid out a pathway for external stimuli to arrive in consciousness through an information processing model. Slide 11. Along the way to consciousness land, stimuli go through a series of processors that interact with some type of storage. Slide 12. And this processing may occur many times, each time interacting with storage to provide meaning to the stimulus when it reaches the land of consciousness. Slide 13. It can happen many more times. And with this new model of the mind, with modules for processing and storage, a new vision of human memory was beginning to form with particular focus on the storage module. Slide 14. Here's an information processing model of memory. As always, fear not. I know this looks daunting and it's a hot mess, so I'm going to take a hot second and break it down for you. Break it down. Before I do, take a look at this slide and pick up what's going down in broad strokes. On the left, we have stimuli from the outside, and it gets passed through a buffer before going into short-term memory, before going into long-term memory, and forgetting seems to happen anywhere along the way. Okay? So now let's take it one piece at a time. Slide 15. It all begins with a signal from the outside world interfacing with our senses. Slide 16. Incoming perceptions are stored in sense-specific buffers from which they vanish almost immediately, fortunately. Why fortunately? Because if they lasted longer, we would see the world as a continuous blur. In that sensory buffer, there are perceptions that we need to retain somewhat longer. So there must be another, longer-lasting form of temporary storage. Slide 17. The percepts in our buffers to which we pay immediate attention gets transferred into short-term memory, while the rest decays within about a second. We'll go over short-term memory in more detail momentarily, but for now think of it as ideas that are a part of current mental activity, but not retained after use, unless rehearsed. Slide 18. If the information in short-term memory undergoes processing, think of the processors and storage slide from a moment ago. And that processing can be rehearsal or elaboration. Those ideas could be transferred into long-term memory. Further, information from long-term memory may be required for the work being done in short-term memory. Whatever is not rehearsed or elaborated on in short-term memory is forgotten and permanently lost. Slide 19. Interestingly, research has shown that even stimuli that are not attended to make their way into long-term memory, and further, that forgotten items of long-term memory can potentially be recovered, if not in a slightly altered version. So let's review. The information processing model compares human memory to that of a computer. Information that enters the system is processed, coded, and stored. When you type something on a keyboard, your computer stores it in a temporary memory. When you store something on the hard drive, you set up a stable, long-lasting representation. According to the information processing model, information first enters short-term memory, a temporary store, and some of the short-term memory transfers into long-term memory, like a hard disk. Eventually, a cue from the environment prompts the system to retrieve stored information. Slide 20. Okay. In talking about memory, I'm sure you've all heard a variety of terms like long-term memory. I just use these terms, right? Short-term memory, but other terms like implicit versus explicit memory or sensory memory, stuff like that. So let's place these terms in their proper place and start going over some memory categories and classifications. Slide 21. Information processing theory distinguishes between short-term memory, temporary storage of recent events, and long-term memory, a relatively permanent store. For example, while you're playing a game, the current score is in your short-term memory, and the rules of the game are in your long-term memory. Long-term memory is further broken down into explicit memory, or memory we can readily state in words, and implicit memory, or memory we cannot readily state in words, each having further classifications, but we'll get into those in a moment. Slide 22. Psychologists have traditionally drawn several distinctions between short and long-term memory. One difference is capacity. Long-term memory has a vast, hard-to-measure capacity. Short-term memory, in contrast, has a very limited capacity. Most healthy, educated adults can repeat a list of about 7 letters, numbers, or words. But you can store more information in short-term memory by chunking, grouping items into meaningful sequences or clusters. For example, the sequence VENTYSI has 7 letters, at the limit of most people's capacity, if we're just using individual letters. However, the word 76 with 3 additional letters can be easily remembered as the number 76, a 2-digit number. The word 1776 is even longer, has even more letters. But if you think of it as the date 1776, an important date obviously in U.S. history, it is a single item to store. Theorists have suggested that our immediate attention holds only one item, and any memory for more than one item at a time depends partly on storage in long-term memory. Other theorists argue that we're wrong even to think about a definite capacity for short-term memory. If you look at an array of a few items and try to remember them shortly afterward, you could be approximately right about several of them and exactly right about just one. That is, you can trade capacity for accuracy. Slide 23. Moving on to decay and forgetting. A short-term memory, by definition, lasts only a short time unless you continue rehearsing it. Well, why do short-term memories even fade? Well, the simplest hypothesis is that the brain representation decays over time. Neuroscientists identified a brain protein that weakens a memory trace, presumably to avoid permanently storing unimportant information. Another hypothesis is that short-term memories fade because we confuse one with another. Suppose you see or hear a set of 5 letters and then you count backward by 3s for some period of time. On the first trial, you'll probably remember those letters, even with a fairly long delay. On later trials, the task gets even more difficult, largely because memory of the old items is interfering with the new items. Well, how long does long-term memory last? It depends. If you're playing basketball, you remember the score, approximately how much time is left in the game, what defense your team is using, what offense, how many fouls you've committed, and so forth. You won't remember that information for the rest of your life, but you also don't need to rehearse it constantly to prevent it from fading. Further, many long-term memories last a lifetime. Slide 24. So let's get a little deeper into the process of memory. Slide 25. And we're going to be picking up on this information processing model right at the short-term memory area, assuming that the stimuli from outside has already gone through the sensory buffer, and what we want to pay attention to has been transferred into short-term memory, and everything else has decayed and is permanently lost. Slide 26. Originally, psychologists thought of short-term memory as the way to store something while the brain moves it into long-term memory. Today, most researchers emphasize temporary memory storage as the information you are using at the moment. To emphasize this different perspective, they speak of working memory, which is a system for working with current information. Working memory is almost synonymous with your current sphere of attention. It includes information you use and then forget. It also includes the executive functioning that governs shifts of attention. The hallmark of good working memory is the ability to shift attention as needed among different tasks. Slide 27. And now let's move on to the long-term memory module for the information processing model of memory. Lots of M's in there. Slide 28. As mentioned earlier, long-term memory is broken down into two further categories: explicit memory, which is memory we can readily state in words, and implicit memory, which is memory we cannot readily state in words. Explicit memory is what I'm testing when I ask multiple choice and true-false questions on your quizzes and exams. Whereas implicit memories are like knowing how to ride a bicycle after years away from one, or knowing the lyrics to a song or jingle you hear all the time but don't really think that you pay attention to. Keep these examples in mind when we talk about how memory is tested. Slide 29. Psychologists distinguish two types of explicit long-term memory. Semantic memory is memory of principles and facts, like what you're taught in school, whereas episodic memory is memory for special events in your life. For example, your memory of the law of gravity is a semantic memory, whereas remembering the time you dropped your grandmother's vase is an episodic memory, both having to do with gravity. Episodic memories are more fragile than semantic memories. When you try to recall an event from long ago, you might be wrong or uncertain about many of the details. People with certain kinds of brain damage lose most of their episodic memories but keep their semantic memories. And people often remember a semantic memory but forget the episodic memory of when or where they learned it. Slide 30. Psychologists also distinguish types of implicit long-term memory. Procedural memories, memories of how to do something such as walking or eating with chopsticks, are a special kind of implicit memories. Psychologists distinguish procedural memories from explicit memories, memories we can readily state in words. For example, if you type, you know the locations of the letters well enough to press the right key at the right time. This is a procedural memory. But can you state that knowledge explicitly? For example, which letter is directly to the right of the letter C? Which letter is directly to the left of the letter P? Procedural memory, or habit learning, differs from explicit memory in several ways. First, the two types of memory depend on different brain areas, and brain damage can impair one without impairing the other. Second, procedural memory or habit learning develops gradually, whereas you often form an explicit memory all at once. Slide 31. We've already spent plenty of time on associative memory as it relates to classical and operant conditioning, so let's just conclude that the power of environmental reinforcers to shape our memory can't be overstated. That is, they're super powerful, and we have a blind spot to them. Blind spots also facilitate the phenomenon of priming, which is one stimulus influencing how someone responds to another stimulus. It's thought to occur when particular mental representations or associations are activated before a person carries out an action or task. For example, a person who sees the word doctor will be faster to recognize the word nurse than he will be to recognize an unrelated word, because the concepts of doctor and nurse are closely related. Slide 32. So now we've gone over all of the modules that exist in this information processing model of memory. Now let's go into, as psychologists, how do we test all these different kinds of memories that exist in these processors? Slide 33. The main methods of testing memory include recall, cued recall, recognition, savings, and implicit memory. A simple method for the researcher, though not for the person tested, is to ask for free recall. To recall something is to produce a response, as you do on an essay or short answer test. The free recall method reveals only relatively strong memories. Slide 34. Accuracy improves with cued recall, in which you receive significant hints about the material. So the example here using the seven dwarfs. If you're given a hint like, one is always smiling, one is smart, yada, 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 it might be a little easier to list the seven dwarves than if you were asked to just name them cold. Slide 35. With recognition, someone chooses the correct item among several options. The advantage of using cued recall and recognition tasks is that they address weaker memories than free recall, which relies on just the strongest memories. Slide 36. The savings method, also known as the relearning method, detects weak memories by comparing the speed of original learning to the speed of relearning. It's a less direct way of testing memory and requires that participants learn something while you collect data on how long it took. Then, at a later date, you have them relearn it to see if it takes less time. If it does, it's inferred that memory has persisted. Slide 37. The methods that we've gone over, free recall, cued recall, recognition, and savings, are all tests of explicit or direct memory. That is, someone who states an answer regards it as a product of memory. In implicit memory or indirect memory, an experience influences what you say or do even though you might not be aware of that influence. For example, if we're going with the seven dwarfs motif, using this missing letter way of determining who the seven dwarfs are, I'm sure it'll be even easier than you thought. Not only do you know who they are, you know how to spell their names. And this happened without you explicitly trying to learn how to spell their names. Slide 38. Some factors that influence encoding. Encoding is just the process of working with something in short-term memory. Emotional arousal enhances memory encoding. Extreme panic interferes with memory, but moderate emotion provides benefits, largely by increasing the release of the hormones cortisol and epinephrine from the adrenal gland. Those hormones stimulate brain areas that enhance memory storage. In addition to attention and memory, many other factors influence how well you store memories. The primacy effect is the tendency to remember well the first items. The recency effect is the tendency to remember the final items. The primacy and recency effects are robust for almost any type of memory. Also, in a list of mostly similar items, the unusual ones are easier to remember. We also tend to remember unusual people. Lastly, people find it easier to remember words they learned in early childhood, for example, apple, orange, banana, than words they learned later. When people see an unexpected sex-related word, it grabs attention so strongly that they pay less attention to the next word and sometimes up to the next 4 or 5 words. Other things being equal, you would probably remember a list of people or animals better than a list of inanimate objects, even if they are familiar objects like stove and hat. Slide 39. According to a depth of processing principle, how easily you retrieve a memory depends on the number and types of associations you form. Right? We're getting back to the associationism theory. When you read a list or read a chapter, simply reading the words without much thought is called shallow processing, and it produces only fleeting memories. Alternatively, you might stop and consider various points as you read them, relate them to your own experiences, and think of your own examples to illustrate each principle. The more ways you think about the material, the deeper your processing, and the more easily you will remember it later. Hint, hint. Slide 40. So over the next couple of slides, I'm just going to break this down. Again, do not be scared. It looks like a mess. But this is called a long-term semantic memory network. And it just shows you how easy it is to build associations that you can sink your teeth into for this deeper processing. You can start with a concept like animal. And immediately you have associations. Animals breathe oxygen, they eat food, they have skin, they move. And you may even start breaking down categories of animals. Mammals, we have birds, we have fish. And thinking about those categories brings forth more associations. Okay, a cow is a mammal, a bat is a mammal, but a bat also flies, so it's kind of like a bird. Well, another bird is an ostrich and a canary. And speaking of fish, we can think about salmon or sharks for right now, illustrative purposes. From there, we can generate more associations. Oh, a cow gives milk, it eats grass, it has udders. A bat has wings and fur and it flies, which is kind of like birds, which fly and have wings, but they have feathers. And fish are in water and they swim and they have fins and gills. That's not the end. We can build even more associations, right? An ostrich is large. We immediately think of largeness when we think of an ostrich. Salmon is edible, pink. I made salmon for dinner just the other night. I did not prepare shark, though. We don't eat shark. They eat us. They bite. They're harmful. And associations can start getting more and more abstract. If we just looked at canary, we would say, obviously, it's yellow. When we think of canary, canary yellow is a color, so we think of yellow. Oh, yellow is a color. I know other colors. Green, red, orange. These are all related to each other. Well, speaking of red color, the thing that comes to mind when I think of red are like cherries and apples, and they both happen to be fruits. And you know what else is a fruit? A pear. So thank you for humoring me through this process, but we started with animals and ended up with pear, using associations in what's called a semantic network. Keep this in mind when you think about memory in general and associations, and the way that you can have deeper processing by taking advantage of all these associations that you have with pre-existing knowledge. Hint, student hack. Slide 49. When you form a memory, you link it to the way you thought about it at the time. Remember the example I gave about the apple? When you try to recall the memory, a cue is most effective if it resembles the links you formed at the time of storage. So for this example, we have fire truck. This process is called the encoding specificity principle, and it takes advantage of the fact that memories are held in storage like a web of associations, as we just demonstrated. Slide 50. So please, as students, take to heart the things that are being doled out in this lecture. This is gold. This is studying gold. Spreading out your study is more effective than studying in a single session. During a single session, you underestimate how much you're going to forget later, and you don't practice retrieving a memory because it's all still so fresh. Long-term memory is best if you study under varying conditions as well. Spreading out examples is better than studying many examples of the same thing at once. Suppose you're trying to learn the artistic styles of several painters so that you can identify new paintings by the same artists. Would you learn better by seeing many paintings by artist A, then many by artist B, then C, and so forth? Or would it be better to see one by each, and then another by each, and so forth? Most people assume the first way is better, seeing many examples by a given artist all at once. However, the results show that spacing them out works substantially better. Also, students seldom get much training on how to take notes. Extremely brief notes do little good, but trying to record every word is impossible. Trying to record everything is tiring, and if you succeed, your notes will be so long that they can be intimidating when you try to review them later. Generally, the best strategy is to try to record the main ideas in an organized fashion. Lastly, alternating between reading and testing enhances long-term memory better than spending the same amount of time just reading. A test forces you to generate the material instead of passively reading it. Also, it shows what you don't know, encouraging you to pay more attention to the material or to study it in a different way. Slide 51. A mnemonic device is any memory aid based on encoding items in a special way. One mnemonic device is to think of an image that'll remind you of what you need to remember. For example, to remember the functions of the sympathetic and parasympathetic nervous systems, you might think of a symphony for the sympathetic nervous system and a parachute for the parasympathetic nervous system. If the symphony excites you, it arouses your sympathetic nervous system. A parachute lets you coast down slowly, like the parasympathetic nervous system. Mnemonic devices can be helpful for remembering people's names as well. For example, you might remember somebody named Harry Moore by picturing them as More Harry. Also, certain things like wedding vows. You can remember the word bristle very easily, and each letter of bristle can represent a different part of the vow. Slide 52. Decades ago, psychologists imagined consolidation as a chemical process that took a fixed amount of time. However, some memories consolidate much more easily than others. When you hear Jakarta is the capital of Indonesia, you might have to work at it to form a lasting memory. If somebody says, "Yes, I will go to the dance with you on Friday," you store that memory immediately. You can try a couple ways to enhance consolidation after learning something. Hint, hint. One is to take some caffeine shortly after learning something. A study found that 200 to 300 milligrams of caffeine, a little more than you would get from an average cup of coffee, enhance the detail of people's memories when tested a day later. Another strategy is to sleep or rest quietly shortly after learning. If you hear something in the background, it's my cat losing his mind. Yes, it seems paradoxical that either increased arousal or decreased arousal enhances consolidation, but those are the results. How long does consolidation continue? Certain kinds of evidence suggest that it continues for decades, but the interpretation of that evidence is ambiguous. Studies found that people in their 60s and 70s remember events from their adolescence and early adulthood better than more recent events. Slide 53. People sometimes imagine that memory is like playing back a recording of an event. However, memory is unlike a recording. Suppose you try to list all the cities you have ever visited. You describe all you can, and then you come back a day or two later and try again. On the second try, you recall most or all of what you said the first time, plus, in the meantime, something may have reminded you of something you left out the first time. This is called hypermnesia. Another difference between memory and a recording is that focusing on one part of a memory weakens the rest of it, at least temporarily. Suppose someone asks you to describe a particular part of an experience. Perhaps, "Tell me about the meals you had on your beach trip." Then, someone else asks you to describe the beach trip in general. Answering the first question strengthens your memory of the meals but weakens your memory of everything else about the trip. A third and most important difference between memory and a recording is that when you try to remember an experience, you start with the details you remember clearly and fill in the gaps with reconstruction. During an experience, you construct a memory. Reconstruction is putting together an account of past events based partly on expectations of what must have happened. Slide 54. Suppose you try to recall studying in the library 3 nights ago. With a little effort, you might remember where you sat, what you were reading, who sat next to you, and where you went for a snack afterward. If you aren't quite sure, you fill in the gaps with what usually happens during an evening at the library. Within weeks, you gradually forget that evening, and if you try to remember it, you'll rely more and more on what must have happened. omitting more and more of the details. Also, while learning the individual words in a list, people also learn the gist of what they're all about. When they try to retrieve the list later, they reconstruct a memory of what must have been on that list. Slide 55. And this brings us to the demonstrations from the beginning of the lecture. All right, I hope you kept your list. So, if, in the first demonstration, the words jazz or melody are on your list, then you've shown the power of the primacy and the recency effect, since they are the first and last words of the list, respectively. If, on the other hand, you had the word music on your list, then that memory was constructed by your mind based on associations to the words that were in the list. To be clear, the word music was not in the list I read at the beginning of the lecture, and you can feel free to go back and listen again. Slide 56. For the second list, rest and dream were the first and last words, respectively, and sleep was my target word that was not actually said in the word list. Check your list and see if these words are on it, and let's move on to the last one. Hand and shoe are our bookends for this final list of words, and the word foot was hinted at without being mentioned. Ain't memory funny? And it gets funnier. Slide 58. People often revise their memories, saying that how an event turned out was what they expected all along. Their behavior illustrates hindsight bias. Hindsight bias occurs for several reasons. We would like to think the world is an orderly, predictable place, and that we're smart enough to predict what will happen. That's not true. We confuse the facts that we know now with those we knew earlier. We also focus on the facts we knew earlier that fit with the later outcome and disregard those that didn't. Then we put together a meaningful story in which the earlier events seem to lead inevitably to the outcome. Slide 59. When someone learns several similar sets of material, the earlier ones interfere with retrieval of later ones by proactive interference. The later ones interfere with earlier ones by retroactive interference. Interference is a major cause of forgetting. So an example of proactive interference would be where you parked your car, right? If you've ever parked your car at a mall that you've been to many, many, many times, the amount of times that you have parked in that mall in the past could interfere with your memory of where you parked your car this particular time. An example of retroactive interference would be calling an ex by the name of your current significant other. An example of retroactive interference would be seeing your ex but calling them by the name of your current significant other. This is an example of new information interfering with retrieval of old information. Moving on to memory disorders. Amnesia is a loss of memory, and it results from many kinds of brain damage, including damage to the hippocampus. Brain damage induces retrograde amnesia and anterograde amnesia. Retrograde amnesia is the loss of old memories, whereas anterograde amnesia is difficulty storing new memories. Slide 62. The following points have emerged from research on people and laboratory animals with damage to the hippocampus. First, storing declarative memory. Storing explicit memory requires the hippocampus. Procedural memories depend on a different brain area, the basal ganglia. Also, the hippocampus is especially important for episodic memories, memories of specific events in one's life. Episodic memories form all at once, unlike procedural memories that develop gradually. Also, the hippocampus is more important for explicit memory than for implicit memory, and more important for difficult tasks than easy tasks. The hippocampus is also especially important for spatial memories, remembering where something is or how to get from one place to another. Patients with hippocampal damage have trouble imagining the future, just as they have trouble recalling the past. According to one influential theory, The hippocampus is critical for remembering the details and context of a memory. It connects to many areas of the cerebral cortex and synchronizes their activity, enabling them to combine their information in recalling an event. When you recall something you did yesterday, your memory is rich in details, including who, what, where, and when. Those details depend on the hippocampus. As time passes, your memory consolidates, but as it consolidates, it changes. You remember the gist of what happened, but fewer details. Slide 63. Patients with Alzheimer's disease have weaknesses in almost all types of memory, although they can learn new skills. That is, they can engage in procedural memory. Alzheimer's disease is marked by accumulation of harmful proteins in the brain and deterioration of brain cells, impairing arousal and attention. The memory problems include both anterograde and retrograde amnesia. Slide 64. And this completes our lecture on memory. This is chapter 7 of your textbook. This lecture was broken down into 3 sections. We started with an introduction to memory, where we defined it, did a basic history, and went over some categories and classifications. We move on to the process of memory, going through the sensory buffers to the short-term memory to the long-term memory. And then we ended with problems with memory or memory disorders, going over amnesia, damage to the hippocampus, and neurodegenerative disorders like Alzheimer's. I'll see you in the next lecture.